So I'd like to sort of work backwards today um, and work with trigonometric functions. And I've actually given three different scenarios, and those scenarios are essentially three different intervals upon which solutions exist for a particular function. Or not really a function, but a trigonometric equation. And the answers are given, and I'd like to perhaps work backwards from the equation itself and their solutions to comparing and contrasting to what we have as actual answers. So for the equation that we're dealing with is, let me go ahead and write this in black here. So the equation that we are dealing with is, so I'm going to write Q for question. It is 3 tangent, it's the cubed of tangent of x equals tangent of x. So the idea here is to, of course, when working with an equation, we want to ideally have the equation set to 0, and then we'll solve for solutions from there. Um, but that's difficult when we have tangent of x on the right-hand side. So there are really two ways to go about this. We could firstly move the tangent x to the other side, which is of course part of the motivation to separate everything or isolate everything on the right hand or the left hand in that case. Or we could divide by tangent of x on both sides and be left with 1 on the right hand side. And of course this is valid, but it questions whether or not tangent of x is 0 because we can't actually divide by 0. So in all cases, at least majoritively, you want to avoid dividing both sides by a particular function, seeing as x for that function could be 0 and dividing would actually be counterproductive. So here, instead of actually dividing, we could instead do 3 tangent 3x minus tangent of x equals 0. And then so we have that equated to 0. And then from here, we can actually factor out a tangent of x. And this is ultimately to get us to a position where we can apply the zero product property. So this is 3 tangent squared x minus 1, because of course tangent x divided by tangent x is 1. And we will then equate this to 0. So we're now in a position to apply the zero product property, which states that if two things are multiplied together and equated to 0, then one of those two things must in fact be 0. And our goal is to figure out which one. And so in the process of doing so, we can find some solutions. So tangent of x is equal to 0, and 3 tangent of x, or 3 tangent squared of x, minus 1 is equal to 0. And we're going to find out solutions by solving this algebraically. So the first one here is to figure out where this particular equation is true. Where is, in fact, the tangent of x equal to 0? Well, in trying to assess this particular fact, we could first acknowledge that the tangent of x equals the sine over the cosine. So sine over x over cosine of x. And for a fraction, for this fraction or any fraction to be 0, the numerator must be 0. And so in fact, we can rephrase this as trying to look for where the sine of x is equal to 0. That would itself be where the tangent of x is equal to 0. And so when we look at the unit circle, we immediately understand that these quadrantal angles, especially the x-axis, is where the y value will be 0. So sine is designated by the y value, or sine is the y value, and then cosine is the x value. So on the x-axis, y would be 0, thus the sine would be 0. So at 0 and 2 pi, which is this point here, sine of x would be 0. And further over, pi would also be a point where sine of x would be 0. So three solutions for this particular case here is to say that that tan of x is equal to 0, where sine of x is equal to 0, which occurs at pi 0 and 2 pi. So these are our solutions for this particular set here for one factor. And the other is essentially going to reap a similar conclusion, but with different numerics. So tangent squared of x, we can say that 3 tangent squared of x equals to 1. And in this case, we could say that tangent squared of x is equal to 1 over 3. And then we could square root both sides, in the process of which we have to add the plus or minus. And we'd be left with tangent of x equals plus or minus 1 over under root 3. This, of course, could be radicalized, or sorry, not radicalized, but rationalized. We could rationalize the denominator, in which case we'd get a more accurate solution. But we're ultimately looking for, again, two things, where the tangent of x equals to plus 1 over under root 3 and minus 1 over under root 3. So this itself will reap different conclusions here, but they are all nonetheless a part of the conclusion as a whole. So immediately it jumps out to say that we already concluded that the tangent of x is sine of x over cosine x. So we're essentially going to take two values of sine and cosine, or rather one value of sine and one value of cosine, divide them, and the end result of that should be 1 over under root 3. Now, what I want to essentially point out here is that when we're looking for a sort of a reference angle, a reference acute angle, we recognize that we can only have about 5. So this is 0 degrees or 0 radians, and this is pi over 6 radians, which is of course 30 degrees, and this would be pi over 4 radians. Actually, yeah, this is pi over 4, and this would be pi over 6, and then this is pi over 2, which is 90 degrees. And the idea here is to recognize that at pi over 2, we would have 0 divided by, we would have the sine over the cosine would in fact be 1 over 0. And at 0, it would be 0 over 1. That is, of course, the tangent. So we can't really get this answer, tangent x being equated to plus or minus 1 under root 3, in we can't get it at this point at pi over 2, and we can't get it at this point. It's only apparent at pi over 6 or pi over 3 rather, and it's not apparent at pi over 4 because we know the values at pi over 4 are actually under root 2 over 2, and the same thing correlates with the sign. So let me actually change this up here. So it can't be pi over 2, and it can't be at 0, and it definitely can't be at pi over 4 because we have the cosine being under root 2 over 2 and the sine being under root 2 over 2. So that's just, dividing that would just get us 1. So it's either pi over 6 or it's either pi over 3. And we recognize that at pi over 3, the sine, or actually let's go ahead and talk about the sine of pi over 3. The sine of pi over 3, 2, 3, 4, 5, is essentially going to be at, let's see here. So we're at 60 degrees, and the sine would be under root 3 over 2. And the cosine at pi over 3, so the cosine at pi over 3, which is in fact 60 degrees, is going to be 1, 2, 3, 4, 5. So the cosine at pi over 3, which is here, is 1 over 2. So the tangent of that, so if we were to take the tangent, which is just the sine over the cosine, which is under root 3 over 2 over 1 over 2, would then come out to be under root 3 over 2, and then of course multiplied to 2 over 1, and this would just leave us with under root 3. That's really not a solution that we want if you think about it. We want 1 over under root 3. So let's try our luck with pi over 6, the other possibility. So pi over 6, this gives us, again, two functions we care about, the sine of pi over 6 and the cosine of pi over 6, because, of course, both of them divided would ultimately reap the tangent. So the sine of pi over 6, if we look at it here, would be 1 over 2, and the cosine of pi over 6 would be under root 3 over 2. And dividing the sine by the cosine would be 1 over 2 over under root 3 over 2, in which case this would be 1 over 2 multiplied by 2 over under root 3. This would in fact give us 1 over under root 3, which is the exact answer that we're looking for. So this essentially tells us that pi over 6 is the reference angle that we're looking for. And so that is itself a solution. So this is so these were solutions, right? And this is also a solution. Pi over 6 is also a solution because that is where the sine over the cosine or the tangent equals 1 over under root 3. But that is only for the positive version, right? We also want to consider the negative version. So the negative version says, where does the tangent of x equal negative 1 over under root 3? Well, in that case, well, actually, for the positive version, we recognize that the sine, let's see, in this case, so there would actually be another solution, I'm suspecting, because positive 1 over under root 3, we're looking for, let's see here. The thing is that if we were to essentially carry on the same assessment, we would also be looking for negative 1 over under root 3. And that would essentially be in a quadrant where a negative is divided by a positive. In that case, we recognize that such quadrants are going to be this quadrant here, where we have a positive x and a negative y. So that is one quadrant to check, and it could also be in another quadrant where, again, we have a negative x and a positive y. So dividing a negative by a positive will give us a negative. So pi over 4, a multiple of pi over 4 will exist in this quadrant, and in this quadrant, which will itself be a solution for where the tangent of x is positive 1 over under root 3 and negative 1 over under root 3. So we discussed where the tangent of x can be positive 1 over under root 3, which was in the first quadrant at pi over 6, but it can also be positive 1 over under root 3 in the fourth quadrant, because you'll recognize that the cosine, or well, it won't precisely, but it will be in a quadrant where the sine is negative and the cosine is negative, because both of those would essentially divide out and give us a positive 1 over under root 3. And that actually occurs in the fourth quadrant. So a multiple of pi over 6 actually exists in quadrant number 4, where the sine divided by the cosine is in fact 1 over under root 3, and that of course would be positive. And in order to find that out, we would just essentially take, we want to place ourselves somewhere in the third quadrant, of course being at a multiple of pi over 4. So what we'll do here is we'll say pi plus pi over 4, which is of course starting from this point and going all the way to pi over 4, which would essentially, or pi over 6 rather, which would essentially bring us to the same point that we were relative in the first quadrant. So in that case, this would just be 6 and then 6 pi plus pi, which is 7 pi over 6. So 7 pi over 6 is also another solution. So just to recap, we wanted to figure out where the tangent of x is positive 1 over under root 3, which was, of course, in the first quadrant, because the sine divided by the cosine at pi over 6 is 1 over under root 3. And if that is true for pi over 6 in the first quadrant, it must also be true in another quadrant where we can somehow divide the sine and the cosine and get 1 over under root 3, which would essentially be at 7 pi over 6, because the negative divided by a negative for the y and the x, respectively, would divide out and become a positive. So pi over 6, and then we have 7 pi over 6 as well. Now we're looking for the negative versions. So the negative versions here would be where the tangent of x equals negative 1 over under root 3. And such a case would exist if we were to take a positive and divide by a negative, and that would occur in quadrants number 2 and in quadrants number 4. So in order to find the multiple of pi over 6, which exists in quadrant number 2, which is in fact a solution, we would want to place ourselves in quadrant number 2 just as we placed ourselves in quadrant number 3. So instead of adding to pi, instead we will subtract from pi. We'll say pi minus pi over 6, which would give us the principal angle. So this would be 6 pi minus pi, which would be 5 pi over 6. So that itself is another solution, 5 pi over 6. And now, as we continue our assessment, we also acknowledge that we would have another angle in the fourth quadrant. And this angle, instead, so we want to place ourselves in the fourth quadrant with a multiple of pi over 6. So we will do 2 pi minus pi over 6, which is why it was so important to figure out what our acute reference angle was. And in this case, we would have 12 pi minus pi, which would just be 11 pi over 6. So these are essentially 11 pi over 6. So these are essentially our solutions in this case. We have pi over 6, we have 7 pi over 6, we have 5 pi over 6, and we have 11 pi over 6. So this is true for, so these are all valid solutions for this particular function here on the interval 0 to 2 pi. And which is why they are actually listed as being from 0 to 2 pi, pi over 6, 5 pi over 6, pi. So actually it seems as though we're talking about the entire, right, of course, we want to in fact include these solutions as well. So we have pi over 6, 7 pi over 6, 5 pi over 6, 11 pi over 6, and pi, 0, and 2 pi. I don't think we should include 2 pi because 2 pi is in fact not included. So 2 pi is then barred from our assessment. So 0 and pi get to stay because 0 is included, and pi is within this particular range. So these are essentially our, so let me go ahead and add this as being a part of our solution. Pi over 6, 7 pi over 6, 5 pi over 6, 11 pi over 6, pi, and 0. And so these are essentially our conclusions. And let me write them. Let me actually try to copy paste them. So now when we're looking at another interval, which is from negative pi to, I believe, to negative, it would be negative pi over 2 to 0. This is our new interval, just to confirm. It is in fact negative pi over 2 to 0, but the brackets are closed instead of opened. So essentially we're not going to include 0 or negative pi over 2 if they are possible conclusions. So negative pi over 2, we want to first assess the angles that we had. So the angles that we had here were 0. We had pi over 6. Okay, and we had 5 pi over 6. So that's somewhere here. And we had pi, so that's here, and then we had 7 pi over 6. And then we had 11 pi over 6. Now, we want to find solutions which are between the interval negative 90 degrees to 0. And what you'll notice is that none of these particular angles fall within this particular interval. 5 pi over 6 is, I think, 115 degrees, and pi over 6 is 60 degrees, or actually 30 degrees. 7 pi over 6 is 210 degrees, and 11 pi over 6, I think, is 330 degrees. And none of these angles fall within this particular range. So should we instead conclude that there are no solutions for this particular interval with this particular equation? Well, that's not entirely true. First, let's try to locate the quadrant which is relevant to us. We're talking about negative pi over 2 to 0. So this would essentially be this range over here. This would be negative 90 degrees, or in other words, negative pi over 2. So this would be the range that we're most concerned with. And we notice that 11 pi over 6 does in fact fall between that range, but it is not 11 pi over 6 that is on this particular interval. It is an angle that is coterminal to 11 pi over 6. It is an angle whose terminal side coexists with the terminal side of the angle that we're calling 11 pi over 6. And so in order to figure out the coterminal angle in this case, if we were to subtract 2 pi, if we were to continue our negative assessment, if we were to go negative all the way like this, we would still be at this location, and then we could then judge whether it's on this particular interval. So if I were to take 11 pi over 6 and go go 360 degrees, which is just going 2 pi, then this would essentially give me 11 pi minus 12 pi, which is just negative pi over 6. So the angle negative pi over 6 is coterminal with the angle 11 pi over 6. And you'll notice that negative pi over 6 is just negative 30 degrees. And negative 30 degrees is, in fact, on this particular interval. So we're not so much concerned about the location of the angle as we are concerned about the coterminal angles, which could fall on this particular interval. So this is our only solution because that is the only angle that we find on this particular quadrant, which correlates with this interval. And now we are looking for negative pi to pi. So this is sort of a different assessment here. So we're looking for, let's see. So in this case now we are looking for negative pi to pi. So again, if we construct our unit circle, we quickly understand that so 0 is here, right? Pi over 6 is here, and 5 pi over 6 is here. Pi is here, and 7 pi over 6 is here. 11 pi over 6 is here. And so what we could judge is that pi to negative pi would actually be, so to go from pi to negative pi or from negative pi to pi, we would actually subtend a 360 degree angle. And that would essentially encompass every single angle that we've listed here. Because 7 pi over 6 is included, 11 pi over 6 is included, pi over 6 is included, and 3 pi over 6, or I think that's 5 pi over 6 is included. But again, it is not so much as the specific angle as it is about the location of the angle. So you'll notice that all these angles, as discussed before, only some of them fall between the interval negative 180 to 180, which is of course the same thing as this interval. Pi over 6 falls between this interval because pi over 6 is just 30 degrees, and 30 degrees is between negative 180 and 180. So our solutions here, pi over 6 is one of our solutions. But then as we continue our assessment, 0 is also on this particular interval, so we'll include 0 as well. And 5 pi over 6, so if we had 5, so 6 can go into 18 3 times, and 3 times 5 is 100. So 3 times 5 is 15, so that's just 115. So 115 is also on this interval from negative 180 to 180. So 5 pi over 6 also is on this particular interval. And since we're including pi, pi is also on this interval, 180. So we'll include pi in our assessment here. And so now we reach 7 pi over 6. So 6 can go into 18 3 times. That's 210. That falls outside our range. And since it does fall outside our range, it is no longer going to be an angle that is on our interval. However, again, it's not about the angle, it's about the location. So there is an angle coterminal to 7 pi over 6 that does in fact fall on this particular interval from negative pi to pi. And if we subtract 2 pi from it, 360, we would eventually arrive at an angle that shares the same terminal side with 7 pi over 6 and is on the interval. So if we do 7 pi over 6 minus 2 pi, we should get 6, and then we'll have 7 pi minus 12 pi, which is 5 pi over 6, negative 5 pi over 6. So negative 5 pi over 6 is also on this particular interval. The same thing can be said for 11 pi over 6, which is 330 degrees, which is outside the range of our interval. And if we again, if we take off one set of 2 pi, then perhaps that falls between our interval. 5 pi over 6 fall, but by the way, negative 5 pi over 6 falls between our interval because this is negative 115, or sorry, 7 pi over 5 pi over 6 falls between our interval because it's negative 115, and negative 115 does in fact fall on this interval. But with 11 pi over 6, we subtract 2 pi, we'll get 6, and then we'll get 11 pi minus 12 pi, which is just negative pi over 6. So negative pi over 6 is also a solution. And so we have these solutions now, basically all of them, that fall on the interval from negative pi to pi. And just sort of double checking here. Yeah. So this is definitely the answer. Let me just go ahead and double check it. So it seems like I did miss one particular solution, which is going to be pi itself, because pi is also on this particular interval. So we'll just go ahead and add pi there. And yeah, that is essentially going to be our final answer.